In this video, you will be introduced to the concept of Bronsted acids and bases, sometimes called Bronsted-Lowry acids and bases. So first, the definition. A Bronsted acid is a substance that donates an H+, a hydrogen ion, in a reaction, H+ often being called a proton. And a Bronsted base is the substance that accepts or receives the hydrogen ion from the Bronsted acid. For example, in this chemical reaction, HCl plus H2O producing H3O plus and Cl minus, we can see that the HCl is classified as the Bronsted acid because it donates an H plus to the water molecule, turning the water molecule into H3O plus and leaving the HCl as Cl minus. Again, HCl loses its H plus, so its formula is now just Cl and with a minus charge because it's lost the positively charged ion. H2O plus, or excuse me, H2O has gained a hydrogen, H3O now, and it's also gained a positive charge, plus. After the acid donates its hydrogen ion, we call it, the substance that it turns into, a conjugate base, and vice versa. The base turns into a conjugate acid. So in this reaction that we just looked at, H3O plus is the conjugate acid of H2O. Because H2O was a base, the substance that it turned into is called a conjugate acid. And likewise, since HCl was an acid, the substance that it turned into, Cl minus, is a conjugate base. We call the acid and its conjugate base a conjugate acid-base pair. So HCl and Cl minus are called a conjugate acid-base pair because of their relationship in this reaction. Water and H3O plus are also a conjugate acid-base pair. One of the things you need to be able to do is look at a substance, knowing that it's an acid, and be able to write the formula for its conjugate base. So here are four acids: HNO2, H2SO4, H2S, and HCN. And if you were asked to write the formulas for their conjugate base, you would remember the definition of an acid is that it donates an H+. That means that the conjugate base of each of these substances will have lost a hydrogen and they will have lost a positive charge. So HNO2 is going to turn into NO2 minus. It lost its hydrogen and its charge decreased by a positive magnitude. H2SO4 will lose one of its hydrogens, so it will become HSO4, and again the charge goes down. H2S also losing one hydrogen, and the plus charge becomes HS minus. HCN losing its positive charge and losing the hydrogen becomes Cn minus. Another thing I want you to be able to do is look at a chemical reaction and identify in the reaction the acid-base conjugate pairs. So here's a chemical reaction that's been provided for you, and if you were asked to pair up the conjugate acids and bases with each other, and one way to do this is just to look across the reaction and find things that look similar in terms of their molecular formula. For example, CH3COO-, if we look over to the right side of the equation, we can see that CH3COOH is really similar in terms of its molecular formula. So those two things are conjugate acid-base pairs. You can see that this one is gaining an H+. That means that this is a base, and this is its conjugate acid. HCN then is paired up with Cn minus. Also, that makes sense because their molecular formulas are very similar. And you can see that HCN is losing a hydrogen and a plus charge to become Cn minus. Here's another example. HCO3 plus, or excuse me, HCO3 minus plus H3OC minus, making H2CO3 and CO32 minus, matching up the acid-base conjugate pairs. And this one is kind of a trick question because there's only one type of reactant, so you can just link one of these up with whatever you want to on the other side. This linking that I've done here, going from HCO3 minus to H2CO3, this is gaining a hydrogen, which means that this is a base and it accepts a hydrogen to make a conjugate acid. This is losing its H+, which makes this the H+ donor. This is an acid, and this is its conjugate base. One more example. H2PO4 minus plus NH3 to make HPO4 2 minus and NH4 plus. Again, to match up the conjugate acid-base pairs, the easiest way to do it is just to look for things that have similar molecular formula. So you should want to pair up the NH3 with the NH4 plus and the H2PO4 with the HPO4 2 minus. The H2PO4 minus is losing a hydrogen. A hydrogen donor is a base, so this is a base, and this is its conjugate acid. And this is gaining an H+, which makes this a base, and this is its conjugate acid. And last but not least, I want you to be able to, similar to what we did in the first example, I want you to be able to look at bases and write the formulas of their conjugate acids. So you would do this by simply adding H+. In this case, HCO3 minus is going to turn into H2CO3 without a charge on it, because not only are we adding a hydrogen ion, but we're adding a plus charge. H3PO4 minus is going to become H3PO4. Again, we're adding an H and adding a positive charge. And over here, PO4 minus will become HPO4 2 minus, adding a hydrogen and adding one positive charge, making the -3 go to a -2. SO4 2 minus will become HSO4 minus. Again, we've added one hydrogen and we've added one positive charge.